This is WBZ Boston.
Now, but they didn't at the time. 1-800-500-4242. We'll be right back on Howie Carr.
Navigating today's healthcare system can be a challenge. What's the best nutrition plan? How do I stay fit? Where can I go for the proper care? Get the answer to all these questions and many more.
I'd like to welcome you to the third installment of the Crystal Radio series. I know some of you have been waiting quite a long time for this one. Sorry for the hiatus, but I've had some other projects going and been doing some stuff at work and have not gotten to this third one, but I hope it's worth your while, worth the wait. What I have in back of me here is a crystal set known as a loose coupler. The loose coupler is kind of the standard of excellence for crystal sets starting from about 1905 up through probably about 1920 when vacuum tube type systems start to take over in a big way. But these continued to be used through the 20s. This particular specimen I have here is an antique, but that's only because I'm an antique. I actually built this in high school back in the early 70s. It's a reproduction of a loose coupler that was found in Electronics Hobbyist magazine of the time, and our esteemed woodshop instructor happened to be a double E, and he wanted a few of us to do some advanced projects that combined both woodworking and some electronics, so this was the project I did. It's built pretty much the same way that loose couplers were built at that time. As you can see, the secondary coil, this is the coil that would attach to the detector in the headphones, goes in and out of the primary coil, and the primary coil is tuned with the slider. This is kind of a large version of what we did in the earlier crystal sets that we've been talking about. Now, as you can see, this is a pretty big unit. It's got a lot of turns. It's got a homemade switch here that allows you to have a tapped secondary. And I remember that switch was made out of brass machine screws that were filed down to form the contacts, and a piece of spring brass. And those are soldered to the taps. I don't know if you can see them or not, but here's the various taps on that secondary coil. Each one of those contacts is wired to those taps. This is basically the design that was made popular and reproduced in great numbers. There's one thing that limits the use of this receiver for AM broadcast use, and that is that it's actually not designed for AM broadcast use. This was designed for the very long wavelengths. Wavelengths from 200 to 2,000 meters and up. So it's inappropriate to use this on the AM broadcast band. As a matter of fact, when I tried to use it on the AM broadcast band, I had to use just about this much of the coil. So all of this is wasted, and only about this much was useful. So when we design our loose coupler in this video, we're actually going to make one that's more suited to the AM broadcast band. And what you're going to notice is it's going to be much smaller than this specimen that is made for the long wave bands. Our loose coupler is really a receiving transformer. It's an air-wound transformer. It doesn't have a magnetic core, so the coupling is through the air. With this type of RF transformer, you've usually got an untuned primary and a tuned secondary, or vice versa. It's air core, and it's close to ideal. There is a parallel inductor in the input that we resonate out by resonating the transformer, and the losses that remain are just the R losses of the wire, any skin effect losses, stray capacitance, what you're winding it on, the form, and so on. And we can talk a little bit about double tuning while we're at this. You guys know about double tuned crystal sets.
In the double tune set, you have both a primary and a secondary that has variable capacitors. It's a little trickier to adjust. Very popular in IF transformer circuits where you need to have a little wider bandwidth. So if we were to apply this to our loose coupler, we could resonate the input, our primary coil, and the secondary coil. But we're going to lose our antenna tuning. So we might have to add another slider in order to tune the antenna. We may have to enhance that either with a series capacitor or series inductor, depending on if the antenna is long or short. And you do see double-tuned loose couplers out there in the world. They do exist.
Next, let's introduce some of the components that we'll need for our construction. We're going to need something to wind the coils on. This is a 2-inch form, common size for small mailing tubes. That would be appropriate for the secondary. And then we need a coil for the primary that will go into. Probably a 2.5 or a 3-inch piece of cardboard tubing that I've put some polyurethane on to make it harder. One thing that helps some of these cardboard tubes stand up to the rigors of punching holes and winding is to put some polyurethane on it to stiffen it up, and that's what I've done with this coil form. In your plumbing supply house, you'll find this lift tank wire set. This is something that's used inside the toilet tank. It's got some nice long pieces of brass tubing. This would work okay for the slider. Now originally when I built the unit in school, I used brass brazing rods. And you know, you could certainly use brass tubing, brass rods, anything like that as the slider mechanism. This was inexpensive and available at the plumbing store, at the hardware store. So I'm going to base it on this. So basically we'll nail this to the back, and then the secondary coil will go back and forth. Now it's not very long. It's probably about 10 inches long, and of course for the broadcast band we don't need to have the big reach of this large set. So this is going to be a little bit smaller crystal radio than the full-size loose coupler. Remember, this is a tune transformer that allows you to do the antenna tuning that we did with our loading coil, the coupling that we did with our primary coil in the second video, and then we have the secondary, and we can vary the coupling in and out. So it's got all of the features that we discussed in the first and second video, all put together into one. It is missing the detector, it's missing the tuning capacitor, and it's missing the output capacitor and the headphones. But other than that, it is a complete tuner. These tuners were also used in other ways in early radio. The idea of this set is to improve selectivity and versatility under very crowded band conditions. So this is quite a step forward from the simple single-tuned crystal radios that we've been talking about. The other thing, it really doesn't matter how you use the set. You could make this the secondary and this the primary. You could hook the antenna up and ground up to these terminals and hook the detector onto the larger coil. It doesn't really matter. It works just as well either way. Examples also that have double sliders on them. This allows you to take the coupled input and move it up and down. It's really unnecessary as long as you've got the ability to go in and out with the secondary coil. I don't see the utility of a dual slider system. The single slider is by far the most popular style of the loose coupler. So I've just got some pieces that I've drilled out, and I'll be finishing these. I just took a piece of pine for the base. It's probably oversized for what I'm trying to do, but I could imagine that it would look something like this. and then it will have the secondary that will go in and out, and then there will be a front that will be for the to pick up the rod. At the end of the rod, I'll probably end up using a die and put a 632 thread on the end of this, and we'll have our own loose coupler. Feature that is missing. Notice how the secondary is tapped and allows you to pick up one or more of the windings, but it does not have the ability to feed the diode or the detector in a place that does not load down the secondary, destroying its Q. You remember in our second video we used a tap point on the secondary coil. We tuned the overall coil, but we went down the coil and attached the diode at a lower point so as to improve the selectivity of the system. They did not seem to use that technique. I have not seen it published. So we're going to try something different this time. We're actually going to make a secondary coil that has additional taps on it to pick up some impedance points that would allow the diode to have a better tap-off point. To do that, we're going to need 3 rods or 3 pickups. So I took a piece of masonite, I formed these discs, and I have swaged in 3 brass standoffs that will pick up the brass tubing. One will be for the bottom of the coil, the other will be for the hot side of the coil, and that's the tapped side, and the center is going to be for the impedance taps on the coil. So we'll have a triple slider system. You can still hook the detector across the 2 outer rods if you choose to, but if you want to try to take advantage of the lower impedance point on the taps, you would attach to the center rod. So we'll have 3 different contacts on the front of the set. Additionally, with a smaller coil, we can think about maybe handling some shortwave frequencies. I'm going to try to accomplish something like 400 kilohertz operation up to maybe 8 megahertz. So this will allow us to do a combined broadcast band and shortwave tuner in one loose coupler.
Okay, let's talk a little bit about construction. And you know, cardboard tubes are fun, easy to work with, masonite. These ideas you know, are simple. Notice I used a rotary switch rather than making my own switch. I'm using pretty heavy wire. The tubing can be bought so that you can get nested tubes as a set, and it costs you a few dollars just to get something like this together. The slider, you know, has to work effectively on top. Remember to use the tape idea when you're making the slider.
So most of the old-time sets were made with enamel wire on the primary slider, and the secondary was wound with a double cotton covered wire, which was a little bit easier to solder to the terminals. You didn't have to strip the enamel, so that was very popular. You could also wind that with Litz wire if you were very careful to get extremely high Q. Here's the completed secondary coil that we're going to be using. Notice it's much smaller, and it'll be suited to the medium and shortwave frequencies. It's wound with a little bit heavier wire. This is actually number 22 enameled wire. So we have a heavier wire to try to improve our Q at the higher frequencies. Okay, let's take a look at the loose coupler. We have the slider up here. This is how we're going to tune the primary. We have the secondary that goes in and out. Got a variable capacitor here and a diode for the detector, and then we have the little 2-tube amplifier. Okay, we've got a jumble of stations right now. Let's see if we can sort this out a little bit.
.com/Ecotech to learn more. This thing is amazing. Epson, exceed your vision.
Mornings begin with Jack Heath and New Hampshire Today.
Join us It's Monday morning on New Hampshire Today with Jack Heath. We'll recap the news that made the headlines over the week.
Okay, I've just tuned in a local station here in Manchester. Again, we have to have the antenna tuned, and we have to actually resonate the station. We get more selectivity when we loosen up the coupling, and we lose a little bit of our signal.
I don't want to put all my money in the stock market with hitting all-time highs and seeing I'm close to retirement, but on the other hand, I'm afraid of losing the bond market if interest rates go up. What should I do?
Visit habagroup.com.
610. See, as you can see, we're only using about this much of the coil for 610. So probably the bottom of the broadcast band goes about this far. That's why I was saying this is a complete waste over here. We're not using this. If we had a very short antenna, we might use, more of the coil, but with a full-size 100-foot, 125-foot antenna, we don't use all of the loading coil. So let's go up in frequency now. And I'm changing the taps so that we're going higher in frequency.
On Heterodyne Radio. Stellar appointees. Remember he was charged with rape. I'm done. I can't believe that I can't find anything on the internet.
Okay, now we're going to try the little guy.
It's a very Democrat state.
This is WBZ Boston.
Now, but they didn't at the time. 1-800-500-4242. We'll be right back. I'm Howie Carr.
Navigating today's healthcare system can be a challenge. What's the best nutrition plan? How do I stay fit? Where can I go for the proper care? Get the answer to all these questions and many more Wednesday mornings at 9 a.m. Call with
Alabama.
on WFBA.
Everyone thought, man, Alabama's going to run through these guys, and they found a way to kind of get it done. So it's all about preparation, situational football, and I think Bob, Coach Stoops have done an outstanding job of getting this team ready for situations like this.
I mean, I think both of these games are really good. Yeah, I'd probably go to the Orange Bowl just because it's nice warm weather, too.
Brush up on the safety plan. Worried about financial problems or are afraid of foreclosure? It's time to take control. You don't have to leave your home. The National Foundation for Credit Counseling can help. Seek advice from our certified housing counselors today. Call us at 86.
Choose from the largest assortment of all 32 teams anywhere. NFLShop.com is your source for the best selection of NFL products anywhere. Go to NFLShop.com or call 877-NFL-SHOP today.
This is Shaq.
Fueled by the National Pest Management
See
Association.
my awesomeness right now. Let me put it to you this way. Go around there.
So we've got one more technical subject that we need to cover, and it's kind of an antiquated term. The term is dead ending, or dead-ended coil. I've got a couple of coils here at my hand. These are both transmitting coils, but it's a good example. These coils are equipped with some taps, and many times with transmitters. The way that we change bands with the transmitters by attaching a rotary switch to the various taps. This is similar to what we're doing here with our slider on our loose couplers, or with our band switch on the loose couplers. We're going along taps in a coil. So let's say we just wanted to use this part of the coil here, the small part of this coil. What would happen to this other part of the coil that's out of the circuit? That's an interesting concept. This part of the coil is known as the dead end part of the coil. It's not being used, it's not part of the circuit, because we're just interested in this part right now. However, this side of the coil still has capacitance, and it has inductance. And one could see that if we had some RF in this part of the coil, that the RF could also be induced in this part of the coil, and there's nothing on the end. And you can see we might have created something. I think they call it a Tesla coil. This is an auto transformer, and it's going to take the voltage here and step it up many times with the unused portion of the coil. These are the types of effects that can occur when you're not taking care of the part of the coil you're not using. In a receiver, you can get some very negative effects where this could actually be resonant at a frequency that you're trying to tune, and it'll take part of the power away that's coming in on the antenna, and it's wasted in the other part of the coil. So it in effect robs the receiver of its sensitivity. That's why they call it a dead end effect. It's an effect that is negative on the part of the coil that you're not using. And much of it has to do with the capacity of the adjacent turns and the resonant frequency that this happens to be at compared to the frequency that you're interested in. So there have been some different ways to overcome it. One of the easier ways of overcoming dead end effects is by using something called a shorting switch. So basically you ground the portion of the coil that you're not using so that you don't get a resonant effect with it.
Just shorting the turns is really not enough. Consider a shorted turn on a transformer. It can take away power as well. And what we're really trying to accomplish is to disconnect the turns, or to put some isolation between the part of the coil we're using and the part of the coil we're not using. Think about that.
So I don't want to completely beat a dead horse, but by the late teens, most of the experimenter and all of the professional grade loose couplers have features that minimize the dead end effect through specialty switches, different types of commutators, and it becomes a really interesting battle of who can come up with the best switch to overcome the capacity effects of having tapped coils. You might have heard of the term Navy coupler. The Navy coupler eliminates the slider altogether, and usually there's two switches on the side of the loose coupler. One is a coarse switch and the other is a fine switch. So think of it as a ones and a tens type of setup on the loose coupler. This also eliminates the problems with the slider, with oxidation and so on. But you'll see all of the ads will mention this effect, and that the feature has been somehow added to the set and making it more valuable. Also at the same time, you start to see plug-in coils come into their own with the honeycomb style or the basket weave style coils becoming very popular, especially at the low frequencies. In order to achieve very high Q and very high selectivity, they get their coupling by putting the two coils in close proximity. All of this comes to naught when the first regenerative receivers come along, and suddenly we can obtain high Q with very inferior type of inductors and tuned circuits. The regen completely turns the loose coupler idea on its head, and it's put on the shelf and never used again, and we move forward from the regen into the super heterodyne and do not look back.
I tried all of these hookups and truthfully didn't see a lot of difference in signal strength between any of them, but what I did notice is there was a difference in the amount of noise caused by sliding the slider on top of the coil. So try some of this and see if you can get some better effects. I ended up with the last setup, but going from the ground side up seems to be the way to go.
These were actually used in regenerative receivers, at least at very low frequencies. You could imagine one could be the tuning part of the regen, and this could be the feedback part of the regen. There are some avant-garde type hookups with the loose coupler using it as a regenerative receiver. And one thing I did with this setup, which is really interesting, is to introduce a beat frequency oscillator and beat it against the incoming signal so you can pick up code stations. This was actually done in the early days, and early vacuum tube local oscillators were used in conjunction with the loose couplers for CW reception. You can very nicely pick up single sideband using a technique like that. Okay, we're listening to CHU Canada at 3.3 megahertz. And you might be wondering why we have the Heterodyne. The reason we have the Heterodyne is we are injecting a signal generator so basically we're putting a signal generator into the ground lead using this this toroid. Okay, let's look at the situation where we are injecting an LO. The local oscillator in this case is the old Hickok signal generator, and the Hickok is coming into a coupling network that's on the ground side of the loose coupler. You can see it's a toroid that's got about 5 turns of wire on each side. It's a 1-to-1 transformer right in the ground lead. So if we want to tune this, and this is a direct coupled receiver, we just go up to the generator, this is the 80 meter band, this is at 3.5 megahertz. A little bit of digital. Not very sensitive tonight, but we are picking up a few stations on the 80 meter band. Just wanted to show you what a local oscillator into the loose coupler can do. So hope you take the time to investigate the loose coupler, maybe build one or restore one. There's plenty of antique devices out there. You're going to pay between probably $80 and $150. They were produced in such great quantities that their prices have actually fluctuated up and down over the last 20 years. And you can find a good example and get one of these on the air. A lot of fun to use. Are they as good as contest grade crystal radios? No, they're not. But they certainly are an interesting device to play with. They will give quite good performance compared to many other crystal sets. And it's a heck of a lot of fun to build something like this. It's a very nice project.